Alright, ladies and gentlemen, writing equations of lines in point-slope form. If you remember from Algebra 1, we did point-slope form and slope-intercept form. I am only concerned about point-slope form, which is good news for you guys because there is no solving for y in point-slope form. What you guys need to understand is that this is what your group test is going to be about. You will take a group test. It will be about point-slope form and writing equations. After that, there will be another, at least one, if not two more of those types of problems on your actual test. So make sure you fully grasp this concept and this type of problem. It's what we will be using going forward. This is just an algebra review. We are going to be applying it to the special segments that we've been learning in this chapter. So, point-slope form. Y minus y1 equals m times the quantity of x minus x1. In this case, and in all cases, m is our slope, and x1, y1, those 2 points, those two variables represent any point on the line. So it has to be on the line, but it can be any point that's on the line. So let's go through and do some quick review of writing equations. In this case, the direction is simply to say write the equation in point-slope form based on the given information. In order to write it, you need a point and you need a slope. That's it. If you have a slope and you have a point, you can input that. The point goes in here, the slope goes in here. So I have a slope, I have a point. If I do this, I'm doing what I like to call setting the table. That's your y equals your parentheses with your x. You have to fill in the rest. Well, we gave you a slope of -2. That goes in here, where your slope goes. This next part isn't hard, but it can be tricky. You have a tendency to do two things. One, you see a -1 and you just bring down a -1 and do it in the same order. You cannot do that. You have to be careful. Your -1 is your x coordinate. Your 9 is your y coordinate. You can only bring those numbers down with the variable that it's associated with. What I mean by that is I have my y minus y1. I need my y coordinate with my y. My y coordinate is a 9. I bring that 9 down. That's tricky part 1. Tricky part 2 is the 9's positive. You actually subtract it then because the formula says y minus your y coordinate. So it's always the opposite here. Okay? Similarly, I have my x coordinate goes with my x variable, but my x coordinate is -1. Well, instead of writing minus -1 is just +1. So we only write it as +1. That's it. I'm not asking you to do anything more. Write your equation in point-slope form. Go ahead, take a second here, hit pause, try number 2. And we should get y plus 7, because your y coordinate is a -7, equals 2/3 your slope, times the quantity of x minus 13, because your x coordinate was a positive 13. And that's all I'm asking you guys to do. I'm not asking you to go any further. 3 and 4 are slightly different because, unlike before, you do not have a slope. You have 2 points. You need to find the slope. The absolute most important thing is being able to find slope at this point. So you need to remember that your slope formula is change in y, which is y2 minus y1, over change in x, x2 minus x1. That's your slope formula that you cannot forget. You do that every time you have 2 ordered pairs. So here, I'm going to first find my slope. y2 minus y1 means I'm going to take my y coordinate 9, subtract my y coordinate 1. x2 minus x1 means I'm going to take the same ordered pair. So I chose 9 to go first. I have to do 2 first for my x. And then I have to go subtract 4. 9 minus 1 is 8. 2 minus 4 is -2. Always simplify your slope. Always simplify your fractions. 8 divided by -2 is -4. Now I have a slope like I had before, but before I had 1 point, now I have 2. It does not matter which point you choose. Both are correct. Let me repeat that. Both points would be correct if you use them accurately. You cannot mix them. I can't use the 4 from here and the 9 from here. But I could use the 4 and 1, or I could use the 2 and 9. My equation could look like y minus 1, my y-coordinate, equals negative 4, my slope, times x minus 4, my x-coordinate. Okay, so if I use this point, that's my equation, and I'm done. Or I could use this point, and my equation looks different. Y minus 9 equals negative 4 times x minus 2. That's if I use this point. You will not be required to do both. You will only be required to do one, and it will not matter which one. Press pause and try number 2, please, or number 4, please. Alright, so first I've just found my slope. I just want to make sure you point out it's always subtraction, but if you're subtracting a negative, you actually add. So use your calculator. Okay, don't be afraid to use that. 1 minus negative 5 is 6. Negative 13 minus negative 3 is negative 10. That simplifies to negative 3/5. That's your slope, so your equation could be y plus 5 equals negative 3/5 times x plus 3 if you use your first point, or it could be y minus 1 equals negative 3/5 times x plus 13 if you use your second point. Alright, our last couple questions here are going to be equally important. And it's the idea of what it means to have perpendicular slope. This may or may not be something that you know already. I know it's taught in Algebra 1. I'm not sure if we taught it here at Warren in Algebra 1 or not. I know in my classes I mentioned it but didn't really focus on it. So this is something you want to pay really close attention to. When your two lines are perpendicular, which is important because we're dealing with altitude, we're dealing with the median, we're dealing with perpendicular bisectors, so we're dealing with midpoints, and in particular perpendicular. When your two lines are perpendicular, their slopes are opposite reciprocals. Okay. Opposite means one's positive and the other's negative. That has to be the case. One positive, one negative. Reciprocal means they are fractions that are flipped. So if you have an A over B, you also have a B over A. So a couple quick examples. Let's say one line has a slope of 3 over 4. That means any line perpendicular to it has the opposite reciprocal slope. So we call this perpendicular slope. I use that symbol. Opposite means if one's positive, the other's negative. This one's positive, your perpendicular has to be negative. And then reciprocal, meaning if it's A over B, the next one's B over A. Well, this one's 3 over 4. So my new slope has to be 4 over 3. That's the perpendicular slope to a slope of 3/4, negative 4/3. Okay. Similar, if I told you you had a slope of, say, negative 2, you would have to find the perpendicular slope to that. This is negative. Perpendicular is the opposite. That means it would be positive. 2 is really a fraction of 2 over 1. Therefore, the perpendicular slope would be 1 over 2. Again, negative, positive, 2 over 1, 1 over 2. That's the perpendicular slope. So a lot of times what you're going to be asked to do in this chapter is to basically identify a perpendicular slope. This line, because it's in slope-intercept form, y equals mx plus b, has a slope of 4/3. The perpendicular slope then is, that's positive, this is negative, 4 over 3, 3 over 4. There's my perpendicular slope. Try to identify the perpendicular slope for numbers 6 and 7, please. Press pause, unpause when you're ready to work it out. So for number 6, you should have a perpendicular slope of -1/8, because this is 8, positive. Perpendicular is negative, which is 8 over 1. This is 1/8. Number 7 is a little trickier, but your slope in number 7 is actually 1. When you don't have anything in front of x, your slope is 1. Well, 1 is a fraction 1/1. So the reciprocal is still 1/1, but it does have to be negative since this one was positive. 8 and 10, apparently I did not like the number 9 when I wrote these notes, is the same thing, but I didn't give you the slope. So just like in our previous problems, you have to find the slope first. So we use our slope formula to find the slope between these two ordered pairs. Okay. Subtract your y coordinates, 4 minus -2, divide by, subtract your x coordinates, 9 minus 5. 4 minus -2 is 6. 9 minus 5 is 4. Gives me a slope of 3/2. Therefore, my perpendicular slope is negative, because that's positive. That's 3/2. This is 2/3, and I'm done. Okay. Press pause and go ahead and try the last problem, please. All right, first, make sure you got the correct slope. -11/15. Now, if you had 11 over -15, there's nothing wrong with that. The idea is, if one of them is negative, it's really the entire fraction that's negative. The only thing you have to be careful of is if you say they're both negative, now you're telling me the fraction's positive, because two negatives make a positive when you're dividing. So, assuming you got a negative 11/15, your perpendicular slope would be positive 15/11, and then you're done. Tomorrow we will be picking up right here, where we are going to start writing equations in point-slope form and understanding the idea of a perpendicular slope. It will be used quite a bit over the next few days and on your group test and on your test.